Hello students, and welcome to the lecture on Information Technology, Basic Concepts. After this lecture, we will be able to learn the following objectives. Understand the concept of information technology. Discuss the history of computer technology. Explain data storage and databases. Describe the data retrieval and data transmission. Understand data manipulation. Explain the academic, commercial, and employment perspective of IT. Discuss the ethical perspectives of IT. Let's start with the basic concepts of information technology. Information technology has great influence on all aspects of life. Almost all workplaces and living environments are being computerized. In order to prepare diploma holders to work in these environments, it's essential that they are exposed to various aspects of information technology, such as understanding the concept of information technology and its scope, operating a computer, use of various tools of MS Office, using the Internet, etc. These form the broad competency profile of diploma holders. Information technology is the use of computers to store and process facts and figures into a useful, organized form. Data is the raw material, numbers and facts. Information is the raw material organized in a useful way. Numbers are data. A telephone book full of numbers is information. To emphasize the role of communications, some people use the acronym ICT, which stands for Information and Communication Technology. Let's now discuss information technology. The term information technology, or IT, refers to an entire industry, and in actuality, information technology is the use of computers and software to manage information. In some companies, this is referred to as Management Information Services, or MIS, or simply as Information Services, IS. The Information Technology Department of a large company would be responsible for storing information, protecting information, processing the information, transmitting the information as necessary, and later retrieving information. Now we will study the history of computer technology. The history has been organized using these widely recognized generations as mileposts. The mechanical era, 1623 to 1945. First generation electronic computers, 1937 to 1953. Second generation, 1954 to 1962. Third generation, 1963 to 1972. Fourth generation, 1972 to 1984. Fifth generation, 1984 to 1990. Sixth generation, 1990 to date. The mechanical era, 1623 to 1945. The idea of using machines to solve mathematical problems can be traced at least as far back as the early 17th century. Mathematicians who designed and implemented calculators that were capable of addition, subtraction, multiplication, and division included Wilhelm Schwickard, Blaise Pascal, and Gottfried Leibniz. First generation electronic computers, 1937 to 1953. The first programs were written out in machine code, i.e., programmers directly wrote down the numbers that corresponded to the instructions that they wanted to store in the memory. By the 1950s, programmers were using a symbolic notation known as assembly language, then hand translating the symbolic notation into machine code. Later programs, known as assemblers, perform the translation task. Second generation, 1954 to 1962. During this second generation, many high-level programming languages were introduced, including formula translation, Fortran, 1956, ALGOL, 1958, and COBOL, 1959. Important commercial machines of this era include the IBM 704 and its successors, the 709 and 7094. The latter introduced I/O processors for better throughput between I/O devices and main memory. The second generation also saw the first two supercomputers designed specifically for numeric processing in scientific applications. Third generation, 1963 to 1972. The first ICs were based on small-scale integration, SSI circuits, which had around 10 devices per circuit, or chip, and evolved to the use of medium-scale integrated MSI circuits, which had up to 100 devices per chip. Fourth generation, 1972 to 1984. The next generation of computer systems saw the use of large-scale integration, LSI equals 1,000 devices per chip, and very large-scale integration, VLSI, 100,000 devices per chip, in the construction of computing elements. Developments in software included very high-level languages such as FP, functional programming, and Prolog, programming and logic. Fifth generation. The fifth generation saw the introduction of machines with hundreds of processors that could all be working on different parts of a single program. Sixth generation, 1990 to date. Many of the developments in computer systems since 1990 reflect gradual improvements over established systems, and thus it's hard to claim that they represent a transition to a new generation. But other developments will prove to be significant changes. Now we will learn about data storage and database. The term data storage can refer to anything with information recorded on it. Using this broad definition, a hardback volume of an encyclopedia, an audio cassette of a pop song, and even a piece of paper with random words written on it would all be considered examples. The most popular definition of the term limits it to only the storage of information on computers and similar devices. On-site storage represents any type of storage device that's designed to remain with the computer or at a single location where the computer is housed. Off-site data storage is one of the most recent types of storage. In this type, information is stored away from the computer at a distant location. Database. A database is a collection of information that's organized so that it can be easily accessed, managed, and updated. In one view, databases can be classified according to types of content: bibliographic, full text, numeric, and images. Now we will study data retrieval. Data retrieval involves the capability to easily select data for graphic or attribute editing, updating, querying, analysis, and/or display. The ability to retrieve data is based on the unique structure of the DBMS, and command interfaces are commonly provided with the software. A backup administrator must be able to locate the appropriate backup media and restore the lost data within an acceptable recovery time objective, or RTO. Excessive recovery time translates to lost revenue and customer relation problems. Some of the most important issues involved in retrieving data from backups are setting the RTO. Recovery is a process, not an event. One of the biggest challenges with backup planning is the establishment of a realistic RTO that will vary depending on the technology in use and the amount of data to be retrieved. Reducing data. Another way to accelerate data retrieval is to reduce the amount of data that must be backed up in the first place. Media management and retention. Data retrieval is also affected by the management and storage of the media itself. Tapes and removable hard drives must be transferred to appropriate storage facilities. Routine retrieval testing. Most storage organizations verify the integrity of their backups by periodically testing the recovery process. For some companies, testing is performed on an ongoing basis as lost user files are searched and retrieved. Now we will study data transmission. Data transmission refers to the movement of data in the form of bits between two or more digital devices. This transfer of data takes place via some form of transmission media, for example, coaxial cable, fiber optics, etc. Types of data transmission. Parallel transmission. In parallel transmission, all the bits of data are transmitted simultaneously on separate communication lines. Parallel transmission is used for short-distance communication. Serial transmission. In serial transmission, the various bits of data are transmitted serially, one after the other. It requires only one communication line rather than n lines to transmit data from sender to receiver. There are two types of serial transmission, synchronous and asynchronous. Both these transmissions use bit synchronization. Asynchronous transmission. When the clocks of the receiving and sending computers are not synchronized, the form of transmission is referred to as asynchronous transmission. Synchronous transmission. When data is to be sent from one computer to another, it's broken up into individual characters and sent in sequence. Such transmission is called asynchronous transmission when the receiving computer uses a clock that's synchronized with the clock of the sending computer. The clock establishes a rhythm. Types of data transmission. Audio data transmission. Video data transmission. Text document transmission. Now we will learn about data manipulation. Data manipulation is the process of taking data and manipulating it in a method making it easier to read or organize. For example, a log of data entries could be organized in alphabetical order, making it easier to view and find information. Data manipulation is also often done with web server logs to allow a website owner to view their most popular pages and traffic sources. Data manipulation language, or DML. Data manipulation language, DML, is a structured computer language used in databases to manipulate the data in some way. A few of the basic manipulations used in data manipulation language include adding to the database, changing a record, deleting a record, and moving data from one position to another. There are two types to data manipulation language. Procedural. The procedural way of coding is often used in business settings and is the proper way of coding the DML request. Non-procedural. In non-procedural data manipulation language, the user only tells the database what datum to work with, but not how to retrieve it. Now we will study the academic perspectives. In recent years, there has been tremendous progress in the area of IT. This has changed our day-to-day activities forever. IT has become a vital tool in modern society, and one has reached the point where societies not having access to IT are at a disadvantage. Nations that come to the forefront in IT arena have enormous economic benefits. In accessing information, the Internet has become the #1 source. Year-end 1998 statistics indicated that more than 147 million people worldwide were accessing the Internet at least once a week from home or office. The number of Internet users was projected to grow to approximately 320 million by 2000, and to 720 million by 2005. The traffic on the internet will double approximately every 100 days. This rapid growth in internet traffic is generating a high demand for both hardware and software products, as well as for skilled IT workers to improve, implement, and manage various systems. Let's now take a look at commercial and employment perspective. In the modern world, acquisition of computer skills is becoming necessary for employment, educational development, and leisure. Computer studies intend to furnish students with a broad knowledge of the nature of information processing and how information and technology is used today. Parallel to the rapid development of information technology is the uprising of certain ethical and professional issues, as well as social implications that were not thought of decades back. The internet particularly made a big impact not only on the way people around the globe communicate, but also it opened a wide door to information. Changes brought about by information technology are in the way one lives, perceives, and does business. The computer is the target and the tool for the perpetration of crime. It is used for the communication of the criminal activity, such as the injection of a virus or worm, which can crash entire networks. Now we will study ethical perspectives. Some say that ethics has to do with religion. Conversely, ethics should not be confined with it. Most religions advocate higher ethical standards, and yet if ethics were confined to religion, then ethics would apply only to religious people. Some say that ethics is something about law. However, there are some unethical acts that are not covered by law. However, conforming to the law is absolutely considered as ethical. Furthermore, some say to be ethical is to do what the society accepts. But the society can be morally corrupt. In this sense, ethics is not generally related to the norms of the society.
Are you going to upload that photo to the internet?
Sure.
You don't mind people seeing you like that?
Do you think I'm stupid? My pictures can only be seen by my friends on Fiesti.
How many friends do you have on Fiesti?
175.
Are there other people in the photo okay with the picture being uploaded?
Well, if just my buddies can see it, there's no problem. Besides, it was a party. If they let somebody take their picture, it can't be that big a deal. If you get your picture taken, it's to show it off, right?
Okay, but how well do you really know all of your online friends? How do you know you can trust them?
Well, I don't know all of them. Some are good friends, others are acquaintances. But I decide who makes the list.
Right, but any of those 175 people can copy your picture with a single keystroke and then do whatever they want to do with it.
Well, yeah. I guess so. But what would they do that for?
And if those friends share your picture with other people?
Nah, they wouldn't do that.
Have you asked them not to? Do they know that you don't want other people to see that picture? They might think it's just a perfectly normal picture and that you don't care who sees it.
Well, since you put it like that... But look, you're driving me crazy. You're paranoid. I already configured my privacy settings, and that's enough. What more do you want?
And if someone sneaks into your private zone?
Impossible. They'd need to steal my password. And I haven't given it to anybody. And I've made it difficult to guess, just in case. Besides, I update my antivirus software all the time to make sure Trojans that could steal them won't get through. You're talking to a pro.
And the other 175? Are they also pros? They also do all those steps to make sure their information is secure.
No, but...
Your private space that no one can get into doesn't really sound that secure, does it?
In social networks, your online privacy can be affected by others. The privacy of others also depends on you.
Information technology has come a long way since then and become a part of our daily routine of everyone's life, both in business and social living. It has drastically developed over the past decades and is still developing fast. The generation of computers becomes smaller with greater speed and capability as generations pass. Now in the end, let us summarize what we have learned in this lecture. In the 1960s and 70s, the term information technology, or IT, was a little-known phrase that was used by those who worked in places like banks and hospitals to describe the processes they used to store information. The information that a computer has at any given time is technically what data its central processing unit, or CPU, can directly access. This information is called memory, and the components that store it are considered primary storage. A database is a collection of information that is organized so that it can easily be accessed, managed, and updated. In one view, databases can be classified according to types of content: bibliographic, full text, numeric, and images. Querying is the capability to retrieve data, usually a data subset, based on some user-defined formula. These data subsets are often referred to as logical views. Data transmission refers to the movement of data in the form of bits between two or more digital devices. This transfer of data takes place via some form of transmission media.